For our third lesson in topic 1, we are going to focus on the midpoint of a segment and the distance between 2 points, or the length of a segment is another way that we can say that. This will be pretty heavy with Algebra 1 skills, which might be like, yay, finally, or it might be like, oh, Algebra 1 and I weren't best friends. But this should be good stuff, I'm hoping. We're going to show things kind of multiple ways on the distance formula side, and then we're going to do some calculation with midpoint formula, and then also work that kind of in reverse. But by the end of the lesson, we should be able to find the midpoint and the distance between 2 points in the coordinate plane. So we're going to use the XY coordinate plane to do these things. Couple things that are a good review to remember is the ruler postulate from the last lesson, where we found the distance between 2 points by subtracting their locations on the number line. For this lesson, we have 2 number lines, the x-axis, which is the horizontal number line, and the y-axis, which is the vertical number line. And so we're going to find distance between points by subtracting. And then, of course, the Pythagorean theorem, which we know, which is a squared plus b squared makes c squared. And so this is hopefully familiar. This is still new, but it's from the last lesson, and so hopefully we're feeling more confident with that. And so when we are talking about the coordinate plane, we've got that horizontal number line. So this is the point where x is equal to 0, where x is equal to 1, where x is 2, etc., etc. We've got vertical lines. X equals 4 is that vertical line. Y equals 3 is this horizontal line. Y is 0, y is 1, y is 2, y is 3. All right, and then each one of these intersections, these corners of these squares, is an x comma y. So the point -3, +2 is here. My hope and my expectation is that you know how to plot points, right? So that's kind of not necessarily new stuff. So if I want to find the midpoint of a line segment in the coordinate plane, if I know where the x1, y1 is, and I know where the x2, y2 is, then I can find out where the middle is by just averaging the x's and averaging the y's. So that's essentially what we're doing. Here's an x comma y, but it's the first point. Here's another x comma y, but it's the second point. If I take the average of the x's, add them up, divide by 2, and the average of the y's, add them up and divide by 2, then I will find the midpoint of the line segment that has these endpoints. All right, so if I want to find the midpoint of the segment that has endpoints at 8, 9, and -6, -3, I can find that midpoint by using what is called the midpoint formula. It's a little bit hard for us to just guesstimate where that middle is. Now we can measure that if we have a ruler, but our measuring devices aren't always precise, and so that's why we will use math, which always is precise, as long as we do the math correctly, correct? So we will write down our formulas, all right? When we do our work in class, the first thing that you're gonna do is write your formula. If you're using the midpoint formula, write it down, because if you don't write the formula, you will not learn the formula. Can I just write it once at the top of the page and then not write it 7 times? No, you're gonna write it every time, because the only way that you're gonna know that formula on exam day, I don't give you the formula, is by writing it down, all right? I want you to be able to recite it. That's why you learn the chorus of the song before you learn anything else, any other parts of the song, because you are hearing that part again. You're saying it again, you're seeing it again. So the more that you see this, the more you will be able to recite it. So write down your formula. Then we'll plug in our values. Now, how do I know what numbers go where? Well, I know that we have an x comma y, and I know that we have an x comma y. So which x is which and which y is which? It doesn't matter. But this is the first x that they give us, and that's the first y. This is the second x that they give us, and that's the second y that they give us. So my x2 is going to be -6. My x1 is 8. My y2 is -3, my y1 is 9. So that's where I put the numbers. And then I get to do arithmetic. 8 and -6 add up to 2. 9 and -3 add up to 6. So now I have 2 in the numerator over 2. I've got 6 over 2. And this equals 1, that equals 3. So the midpoint is at the point 1, 3. Look at that. It's right there. This is the midpoint M. All right, so we can find that middle point doing algebra. Now, for example B, what I would like for us to think about here is, if we know where the midpoint is, how do we find the end points? So this one's a little bit tricky, And so what I want you to do is I just want you to make a little star there, and I want you to write tricky, 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 tricky. And the reason why it's tricky is because you're going to do that formula backwards. We're going to take that formula apart, and we're going to do the same stuff, just reverse, reverse. We do not know the other endpoint, all right? We do know that we have 1, 4 for point D. We've got -1, 5 for point M. And so you can probably tell if this is the midpoint, if I continued that on for another similar distance, that we would find that the midpoint is at -1, 2, 3, +1, 2, 3, 4, 5, 6. So at -3, 6 is where point G is going to be. All right, but I don't have a coordinate plane necessarily handy all the time. We're going to show you how to do this algebraically. All right, and that's going to be the expectation when we work on this in class, is that we can do this algebraically. I know the x value of my midpoint. This is x and this is y, but this isn't my x1 or my y1, or I'm sorry, my x1 or my x2. This is the x value of the midpoint. And this is the y value of the midpoint. This is my x1 and this is my y1, but for G, this is going to be my x2 and my y2. That's the second point, first point, second point, and there's the one in the middle. So how can I find which one is which? Well, I know that this is the x value of the midpoint, and I know that this is equal to the y value of the midpoint. So instead of having everything kind of condensed in one, like on example 1a, for here we're going to separate that out because I know that this number is -1, and I know that this number is 5. I know x1 is 1, I know y1 is 4, but I don't know what x2 is and I don't know what y2 is. So I have these funky equations that I have to solve for. And that can be stressful because, oh no, there's an equation involving fractions. All right, I know that that's stressful because Algebra 1 is hard, all right? But in Algebra 1, Chapter 2, we learned that if we have an expression divided by some denominator, we can get rid of the fractions by multiplying by the denominator. So if I multiply both sides by 2, if I multiply this side of the equation by 2, and I multiply that side of the equation by 2, I will get rid of that fraction. If I multiply this side by 2 and I multiply that side by 2, I will get rid of that denominator, that divisor. So instead now, I've got the numerator equals twice the x value of the midpoint. I've got this numerator is equal to twice the y value of the midpoint. And now it's just a subtraction question. Subtract 1 from both sides, subtract 4 from both sides. And, oh, like I said, -3, 6 is the location of the other endpoint. So this one's a little bit tricky because you have to think about how to do your algebra. Next, we're going to talk quickly about the portion of a segment. What if we want to find a point that's not halfway across, but we want to find a point that's a third of the way, or a fourth of the way, or 3/4 of the way between the endpoints? Essentially what we had there is we took the average, we found halfway between those x's and y's. And we're going to do things a little bit differently. To find this, we kind of have to find the horizontal distance first, and the vertical distance second, and then we're going to apply a fraction. But that's going to be from one way or the other. Are we saying halfway from the rightmost point to the leftmost point, or from the leftmost point to the rightmost point? Those might not be the same location. So this becomes a little bit different because then we have to apply that fraction to that horizontal or that vertical distance. I know that can be a little bit backwards. So what are the coordinates of point P? This is extra tricky, all right? But the math is very doable. It's just how do we set it up well, Mr. But I want to do a good job. So here we have A and B, and this will be like x1, y1, this will be x2, y2, and this is our multiplier. All right, that's what we're going to be multiplying. So we want to make sure that we can find the horizontal distance there. So from A to B on the x, we're going to take the absolute value of x2 minus x1. We're going to take the vertical distance, y2 minus y1. All right? And when we do that, we are going to find that horizontal distance. So I'll do 13, minus 3 gives us 10. I'll do 11 minus -4 gives us 15. So this is the horizontal distance, and this is the vertical distance. The difference between the x's is horizontal, the difference between the y's is vertical, right? And now we're going to apply that fraction. We're going to do 3/5 times the x change gives us 30 over 5 makes 6. And 3/5 times the vertical distance gives us 45 divided by 5 is 9. And so these are the amounts that we are going to add to the x comma y from point A, because we're working from point A to point B. And so I'll do 3 plus 6, comma, -4 plus 9. And this gives me the point P, which is going to be located at 9, comma, 5. So I know that might have been a little bit confusing, but we're going to find that horizontal and that vertical distance, and we're going to add that to our original x comma y. So watch what happens here. Let's show what that looks like. Oh, I did all that on the thing. I didn't know that it was all typed in there. That's really fancy, Mr. Hibbett. I'm glad that that's all typed. I'm glad I was able to do all that math and do all those things. But here we go. Yay, it's all typed. So what I want to show us, though, is what that looks like on the coordinate plane. Because I think it's valuable to see it, and then you can believe that it's true. So here we have the point 3, -4, bloop. And here, 13, 11 is going to be off the picture. 1, 2, 3, and then 1. So I'm going to go way over here. This is about the point 13, comma 11. This is the point 3, comma -4. And I'm going to connect those. I'm going to connect those as best I can. All right. And the point that is 60% of the way from point A to point B is going to be at the point 9, comma 5. All right? That point is 3/5 of the way from point A to point B. Does that look like it's more than halfway? It's not quite the midpoint. It's more than halfway. It's about 60% of the way over to point B. Hopefully, yes, if you know percentages and fractions pretty well. So I just wanted to model that for you. We're not going to necessarily use graphing paper for that, but that will maybe help us to understand things a little bit more clearly when we visualize that. All right. Part 2. So that was part 1. That was all about midpoint formula and finding the place that is a fraction of the way between the endpoints of the segment. But now we're going to talk about the Pythagorean theorem. So this is kind of a nothing new approach to finding the distance between point R at -2, 6 and S, which is at +8, -5. If I want to find the distance between those 2 points, the way that I can do that is I can just imagine that this is a right triangle. All right, a right triangle. It's a little bit tricky to kind of think about it that way. It's less tricky to actually draw it out using your graph paper. But again, most of us probably don't have our graph paper at home. Do we? Did we go to the store and get those yet? We don't really need that quite yet. If you don't have it, it's not the end of the world. But we should notice that this is a right triangle. And you know that if I do a squared plus b squared, that gives me c squared. And I don't know which side is a and which side is b. Again, that doesn't matter. But a squared plus b squared makes c squared. And then if we know what c squared is, I can take the square root, and I can therefore then approximate the length of that segment, or I can write it in its simplest radical form. So, oops, A we do is the horizontal distance, my bad. All right, so this is A and that's B. The horizontal distance is going to be the difference between the x's, all right? That's a distance of 10. And then the vertical distance is a distance of what, 11? Yeah, so we've got 8 minus -2, -5 minus 6. We get A is 10 and B is 11. So this is 11 units long, this is 10 units long. So I can use now the Pythagorean theorem that a squared plus b squared is c squared. So 100 plus 121 is going to give us the hypotenuse squared. All right? And so the square root of 121, which is almost 15. Almost 15. 14.9. Now, when it comes to doing the Pythagorean theorem, which I know is not a new thing for you, we could do all of those steps. Right? It's not necessarily very difficult, but let's count all these steps. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 steps. All right? And you might look at that and say, none of those steps is difficult, Mr. Hibbett, so who cares if there's 14 easy steps? I don't care if there's 14 easy steps. That sounds great, and you probably shouldn't either. But you would probably prefer to have fewer steps and maybe have it more condensed, etc. Now, on occasion, we will learn something new that uses something old and just kind of reorganizes it. All right, that's what happens all the time in Algebra 1, right? It's like why we learn something new? We just did it this way. It's like, yeah, but we can also do it this way, and it's maybe a little bit shorter. And so that's what we're going to do. I'm going to show you something called the distance formula. The distance formula. And this is something that you might have seen in Chapter 11, Lesson 2, if your Algebra 1 teacher covered that last year. If not, then whatever. This is the distance formula. The distance between 2 points, the distance from A to B, or the length, using our new notation, the length of line segment AB, is found by taking the difference in the x's and squaring them, the difference in the y's and squaring them. You add those quantities together, and then you take the square root. All right? That's what we did, right? We found the difference in the x's and squared it. We found the difference in the y's and squared it. We added them together, and then we took the square root. Instead of doing those as all separate things, what if it is contained like this? So doing that same exercise that we just did, where we found that the length of the hypotenuse was about 14.9, the square root of 221, I can show you that taking the difference in the x's and squaring them, the difference in the y's and squaring them, just organizing it all in one coherent spot, we can find that we've got 10 squared and negative 11 squared. What's going to happen when I square that? Well, 10 times 10 is still 100, and negative 11 times negative 11 is still a positive 121. I add those together and I take the square root. So instead of doing 14 separate things, I do 1 step, 2 steps, 3 steps, 4 steps, 5 steps, and a half step, right? Typing that in the calculator. All right, so 6 steps, if you want to call it that, is fewer than 14. You're still doing all the same things, it's just that it's organized very clearly here, instead of that hodgepodge of we're doing these x's and y's, and I got to put them together in here, and then I got to do that other thing. Here, it's all streamlined together. So the exhortation is that you are going to use this formula so that you can learn the new thing, and if on a quiz or a test you want to just not regurgitate the new thing, or not do the new thing, you want to say, I'm just going to use Pythagorean theorem, then you can do that on your test. All right, that is really the end of the lesson. Midpoint formula and distance formula. There's also that tricky spot where we did the portion of the segment. Let me know if you have any questions.